Dear friends, hello everyone. I am here, Dr. Kalimuddin Momin, going to deliver the lecture in organic chemistry. In organic chemistry, very important branch that we are going to discuss, that is stereochemistry. Actually, this is branch in organic chemistry, but only one unit we have kept in our syllabus. So in this stereochemistry, we are going to discuss one of the important concept, phenomena we can say, that is isomerism. Friends, you know, there are a lot of organic compounds are there. Many organic compounds are there that have same number of carbon atoms, same number of hydrogen atoms, and even same number of oxygen atoms. But although they having same numbers, but they differ in their physical and chemical properties. So such thing we are going to discuss here. Such compounds which they have same number of carbon atoms, hydrogen atoms, oxygen atoms, means they have same molecular formula, but differ in their physical and chemical properties. Such compounds are called as isomers of each other, and the phenomenon is known as isomerism. So today we are going to discuss this phenomena, isomerism. First, in organic chemistry, many word itself represents its meaning. Here, you know what I have said you, isomerism. If you see this word, isomerism, this word derived from iso and meros. Suppose I divide this isomerism word into, that is iso and meros, and overall it becomes isomerism. Means iso means equal, meros equal parts. So equal parts, accordingly the name is there, isomerism. As I have already said you, having same number of carbon, same number of hydrogen, same number of oxygen, that's why this word becomes isomerism. So I think you might understood that definitely the compounds having same molecular formula and which differ in their physical and chemical properties, such compounds are called as isomers of each other, and overall phenomenon is known as isomerism. So we are going to discuss in details now regarding this isomerism. This isomerism again has two types: structural isomerism and chain isomerism. Obviously, the name itself indicates again structural isomerism. The compounds having same formula, but they differ in their structures, and because of difference in the structure, such compounds differ in their properties. That's why such compounds are called as structural isomers, and phenomenon is known as structural isomerism. This structural isomerism, depending upon the arrangement of atoms or groups, they have again different types. We will see one by one here now. Now the first slide, what I have mentioned here regarding the first type, that is chain isomerism. Now the definition is on your screen, what I have put up here. The compounds having same molecular formula but differ in carbon chain. Now see again, what is the first type? The name of the first type is chain isomerism. So again the name itself represents definitely there must be change in the carbon chain. Okay, what I am saying. So the compounds having same molecular formula but differ in the carbon chain, such compounds are called as chain isomers of each other, and overall phenomenon is known as chain isomerism. Now, this definition, this definition definitely we have to clarify with some examples. I will put some examples. Definitely, your concept becomes more clear now. Now, the first examples on your screen, what I have put up regarding the chain isomerism. See here, I have put up two organic compounds here, butane and isobutane. You know, butane obviously having four carbons, and its isomer, what I have put up here, also having four carbons. If you see the difference in between these two, one that is N butane having normal chain, CS3, CS2, CS2, CS3, means these carbon are present in the normal chain, in straight chain. The same molecule having the same number of carbons, but here there is branching. On second carbon, one methyl group is there. Means only change in the carbon chain. If you count number of carbons, if you count number of hydrogens, obviously they are same. You can check yourself how many carbons, how many hydrogens. Definitely they are same in number, but one is N-butane having straight chain and another is isobutane which is having branching. Means on second carbon one methyl group is there. Means overall there is change in the carbon chain. Such compounds, that is butane and isobutane, are chain isomers of each others, and you can say the phenomenon is chain isomerism. Not only one example. Suppose I have put next example, that is what I have to put up here. Now, very interesting examples again I have put up on the screen. The carbon having, the compound belongs to alkane and having 5 carbon each. See, you can check yourself. CS3, CS3, CS2, 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 CS3. Means how many carbons? Obviously 5 carbons are there. Again, second example of the second example in the sense it's isomer of the first, what I am saying. So again there are 5 carbons. In third, again there are, if you look there on the screen, again there are 5 carbons, but there is change in the carbon chain. Number of carbons are same, number of hydrogens are same, but there is change in the carbon chain. In first example, straight normal chain is there. That's why we can say it is a N-pentane, normal pentane. Okay, always we will write small n, N-pentane, if it is present in the straight chain. Now, the second molecule, what I have put up on the screen, on second carbon, one methyl group is there. But there is number of hydrogens or carbons are same. There is only change in the carbon chain. What I am saying, there is branching. There is branching on second carbon. One methyl group is attached on second carbon. And in third example, again on second carbon, 2 methyl groups are there. There is branching. So, you know the names N-pentane, isopentane and neopentane. These 3 compounds having same molecular formula but differ in the carbon chain. That's why they are called as chain isomers of each other, and phenomenon is known as chain isomerism. See, because of this difference in the chain, obviously they having different chemical and physical properties. If you observe their properties, definitely they are differing from one another. So we can put this example in chain isomerism. Again, I will repeat, N-pentane, isopentane and neopentane are the examples of chain isomers, and phenomenon is known as chain isomerism. Now I will go further again. See, now after completing the first type of the structural isomerism, that is chain isomerism, what I have explained with example, now I am moving the next type of the structural isomerism to deliver on this thing, that is position isomerism. Now again the name itself represents something regarding the position, because in the title already is given position. So definitely this word itself represent definition. Now here on the screen I have put up the definition. Position isomerism. Position isomers have same molecular formula but differ in the position of functional group on the carbon chain. See what I am saying? Only change in the, obviously they have same molecular formula, because actually they are this is the type of the isomerism. So obviously they having same molecular formula, but what is the difference? Difference in the position of functional group. First examples I have put up here with the names 1-bromobutane and 2-bromobutane. If you look this example, that is bromine is here on the first carbon. In second example, bromine is on second carbon. Means position of that group is changed on 1 and 2 respectively. That's why they are called as 1-bromobutane and 2-bromobutane. That's why, because of the change in the position of functional group, these two compounds are regarded as a functional isomers of position isomers of each other, and phenomenon is known as position isomerism. We will put more example, the concept becomes more clear. Just I have put up example of 1-bromobutane and 2-bromobutane, which belongs to position isomerism. Now here again the examples that will clarify the concept of the position isomerism. N-propyl alcohol and isopropyl alcohol. Very interesting example I have put up here. The alcohol having functional group OH, you know, and both having same, that is OH, OH. But if we look the example, the position of OH is changed. In first example, the functional group OH is attached to the carbon number 1, and in second, the OH group is attached on second carbon. Means OH is attached on carbon number 1 and 2. Obviously, overall number of carbons, hydrogens, and even OH is same, but they are totally changed as far as their physical and chemical properties. That's why N-propyl alcohol and isopropyl alcohol, because of the change in the position of OH groups, they are called as chain position isomers of each other, and phenomenon is known as position isomerism. So here again the example, just to bring out the clear concept of the position isomerism, I have again here given 1-butene, 2-butene. That is here double bond is there in the chain. You know butene, that is alkene. ENE, the word itself stands for unsaturation, presence of double bond. Butene and butene, but here the position of double bond is on carbon number 1 and carbon number 2. If you see in this case, the double bond is present on carbon number 2, and in first case the double bond is present on carbon number 1. That's why the name is 1-butene and 2-butene. Position of double bond is on carbon number 1 and 2. That's why these two, that is 1-butene and 2-butene, are the position isomers of each other, and phenomenon is known as position isomerism. And again, the just to clarify the things regarding position isomerism, again I have put up the example of here 2-pentanone and 3-pentanone. ONE. ONE, what it indicates? The presence of ketonic group, C double bond O, here C. But 2-pentanone means definitely the carbonyl group C double bond O, that is ketonic group you can say, present on carbon number 2. And obviously 3-pentanone, that is the ketonic group, will present on carbon number 3. And overall see, there are 5 carbons, hydrogens numbers are same, but name is because of presence of ketonic group on carbon number 2 and carbon number 3, means position of functional group is changed. That's why they are called as position isomers of each other. 2 pentanone and 3 pentanone are position isomers of each other, and that is phenomenon is known as position isomerism. I hope you have understood, because I have taken 4 examples with different nature. That's why definitely the concept becomes I think it is clear for you. Now again, one more examples on the screen, which what justify the position isomerism. That is benzene there, having 2 chlorines on their site, and chlorine on carbon number 1 and 2 in second example, that is carbon number 1 and 3. That's why 1 2 position is called as ortho position, and 1 3 position is 1 3 means number carbon number 1 2 and 3, is it? It is called as in organic chemistry meta position. Ortho position, meta position, you know very well. That is 1 2 position is ortho, 1 3 position is meta, and name number of carbons, number of hydrogens, number of chlorines are same in both cases, in both organic molecules, but only change in the position of chlorine atom, that is on 1 and 2 or 1 and 3. That's why these two, that is orthodichlorobenzene, metadichlorobenzene, are the example of position position isomers, and phenomenon is known as position isomerism. So after completing position isomerism, now we are moving towards the next isomerism type, that is what I have entitled on the screen, that is functional isomerism. So now again the word itself represents functional. Definitely the definition is oriented with the functional group again. But what is definition? Functional isomers are those compounds having same molecular formula but differ in the functional groups. Such organic compounds are functional isomers of each other, and phenomenon is known as functional isomerism. Means 2 compounds are there, they having same molecular formula but differ in their functional groups. Very interesting. Now see the first example. Definitely that example will bring out the clear concept of the functional isomerism. CS3 CS2OH, obviously it belongs to alcohol. OH is there, functional group OH is there, and in this example CS3O CS3, dash O dash, this functional group designates as ether. If you look these 2 examples having same number of carbon, hydrogen and oxygen, 2 carbons are there, 6 hydrogens are there, and only 1 oxygen in both cases. This 1 oxygen is 1 oxygen. Means carbon, hydrogen and oxygen numbers are same but totally change, because in first example it belongs to alcohol because presence of OH functional group, and the next molecule example represents ether because of presence of ethereal oxygen there, dash O dash, that is called as ethereal oxygen. So one is alcohol, one is ether. Obviously they have same molecular formula but totally change in the functional group. That's why ethyl alcohol and dimethyl ether represents functional isomers of each other, and phenomenon is known as functional isomerism. Only 1 examples I have put up, but we have to clarify the things regarding the what I have to say here, that is acetone and propanaldehyde. The one more example here I have given, the formula of acetone, propanaldehyde. Acetone having ketonic group, propanaldehyde having aldehydic as a functional group. Mind it well, aldehyde functional group and ketonic functional group, means both have same molecular formula but differ in their functional groups. That's why acetone and propanaldehyde, that is called as functional isomers, and phenomenon is known as functional isomerism. Some examples what I have put up here again, for the justification. See, just to clarify the more examples I have put up here: diethyl ether again, acetic acid and methyl formate. One more examples, that is what I am going to explain regarding this. Acetic acid, it is obviously it is acid, and methyl formate, one type of ester. So one is ester, one is acid, and obviously they are the having same molecular formula, that belongs to functional isomers, and phenomenon is known as functional isomerism. So these examples justify, clarify you regarding the functional isomerism. I hope you have understood regarding what is mean by functional isomerism. Now I will move for the next type of the structural isomerism, that is metamerism. So just read first the definition of this metamerism. That is, this type of isomerism is due to unequal distribution of carbon atoms on either side of the functional group. Very interesting. Means there is, what I have to say, that is unequal distribution of the carbon atoms. Such compounds are called as metamers of each other. Phenomenon is known as metamerism. Examples, that is diethyl ether and methyl propyl ether. If you look in the examples, definitely you can come to conclusion that having same number of carbons, same number of hydrogens, same number of, that is oxygen is there, ether is there, but there is unequal distribution on over the either side of the functional group. See here, oxygen, which is ethereal oxygen, on either side there are two carbons, on this side there are two carbons. Means this ethereal oxygen, two carbon on either side, two carbon on other side. But if we look to this another molecule, in which on this side only one carbon is there, and on other side there are three carbons, means there is unequal distribution. In first molecule, that is there is distribution like two carbons on ethereal, around the ethereal oxygen, and in second molecule on one side one methyl group, and on second side there are three carbons. Means overall there is unequal distribution of the carbon atoms on either side of the functional group. So diethyl ether, methyl propyl ether are the metamers of each other, and overall the phenomenon is known as metamerism.